A troubling pattern is emerging across America's agricultural heartland, and it is raising difficult questions about the future of one of the world's most productive farming regions. What does it mean when wells begin pulling air before crops have even finished being planted? What happens when winter wheat fields fail across vast stretches of land? At what point does a drought stop being a temporary hardship and become a long-term transformation of the landscape itself? These questions are becoming increasingly relevant in Nebraska, where farmers entered the growing season facing conditions that many describe as among the most severe seen in years. By the middle of May, reports began circulating from parts of the state that wells were already struggling to deliver enough water. In some locations, pumps that normally provide reliable irrigation were drawing air, an indication that groundwater levels had fallen far enough to interfere with normal operations. The timing could hardly have been worse. Planting season was still underway. Corn and soybean producers were placing seeds into fields while simultaneously confronting the possibility that the water needed to sustain those crops through the summer might not be available in sufficient quantities. Irrigation systems that typically provide a sense of security against dry conditions suddenly became sources of uncertainty. The situation has become alarming not simply because of the drought itself, but because of the speed at which conditions deteriorated. Nebraska is no stranger to dry periods. Agriculture across the Great Plains has always been shaped by weather extremes. Farmers have endured droughts, floods, heat waves, and cold snaps for generations. Yet the combination of depleted groundwater, failed winter wheat, widespread wildfire activity, and unusual insurance claims suggests that something larger may be unfolding. Winter wheat has emerged as one of the clearest indicators of the severity of the situation. Across portions of Nebraska, the crop has suffered extensive damage after months of inadequate moisture. Wheat planted during the previous autumn depends on soil moisture reserves and winter precipitation to establish strong roots and survive until spring growth begins. When those moisture reserves disappear, the crop's prospects decline rapidly. This year, many fields never received the moisture necessary to support healthy development. Large areas of winter wheat struggled through the winter and entered spring already under stress. As temperatures increased and precipitation remained limited, conditions worsened further. Some fields that would normally produce substantial harvests yielded little promise at all. For producers who depend on wheat revenue, the losses are significant. Unlike some crops that can potentially recover after receiving later season rainfall, severely damaged winter wheat often has limited opportunity for improvement once critical growth stages have passed. By the time many producers assessed their fields this spring, the damage was already evident. The challenges facing wheat producers are occurring alongside another striking statistic. Approximately 775,000 acres, equivalent to roughly 1,211,000 square miles, or about 313,000 hectares, burned across Nebraska during the spring fire season. The scale of those fires reflects the dryness that has taken hold across large portions of the state. Vegetation that might normally retain moisture instead became fuel. Strong winds, low humidity, and parched grasslands created conditions favorable for rapid fire spread. Wildfires are often associated with forests and mountainous regions, but grassland fires can move with extraordinary speed. Across the Great Plains, fire has always been part of the natural environment. However, when drought intensifies and fuel conditions deteriorate, the scale and frequency of fires can increase dramatically. The spring fire season demonstrated just how vulnerable the region can become when moisture disappears. Fire crews confronted numerous blazes that consumed grazing land, agricultural fields, fences, infrastructure, and wildlife habitat. The losses extended beyond the immediate burn areas. Ranchers faced reduced forage availability for livestock. Communities encountered heightened risks to property and transportation networks. Perhaps one of the most revealing developments has been the emergence of prevent plant insurance claims on irrigated ground. Such claims occur when conditions prevent farmers from planting crops within established timeframes. Historically, irrigation has served as a powerful safeguard against weather-related planting disruptions. The presence of irrigation infrastructure generally reduces the likelihood that producers will be unable to establish crops. Yet reports from Nebraska indicate that prevent plant claims are occurring even on land equipped with irrigation systems. That development highlights the central role groundwater plays in the state's agricultural economy. Irrigation equipment alone cannot guarantee water availability. Pumps, pivots, and pipelines depend on sufficient groundwater supplies. When aquifers decline or wells lose productivity, irrigation systems become less effective, regardless of the technology installed above ground. Nebraska occupies a unique position within American agriculture, because much of the state overlies portions of the vast Ogallala Aquifer, one of the largest groundwater systems in the world. Stretching beneath multiple states across the high plains, the aquifer has supported agricultural expansion for decades. The availability of groundwater transformed regions that would otherwise face significant production limitations. Farmers were able to cultivate crops at scales previously impossible in many semi-arid areas. Corn production expanded dramatically. Livestock feeding operations grew. Rural economies became deeply connected to groundwater-supported agriculture. Yet the aquifer is not an unlimited resource. Groundwater accumulates over long periods, often requiring decades, centuries, or even longer to recharge fully. The balance between withdrawal and replenishment varies considerably from one location to another. Some portions of the aquifer receive relatively greater recharge from precipitation and surface water interactions. Other areas experience recharge rates that are far slower than withdrawal rates. Over time, persistent pumping can lower groundwater levels. In some parts of the high plains, declines have been documented for decades. The consequences are not always immediately visible. Water continues flowing through irrigation systems, crops continue growing, and agricultural production continues. However, gradual declines can eventually reach thresholds where impacts become increasingly difficult to ignore. The reports of wells pulling air in Nebraska have focused attention on those concerns. While individual wells may fail for various reasons, widespread observations of declining performance during planting season raise questions about broader groundwater conditions. The implications extend far beyond a single state. Nebraska sits near the center of a vast agricultural corridor that stretches across much of the Great Plains and Midwest. Crops grown in this region contribute significantly to domestic food supplies, livestock feed production, ethanol manufacturing, and export markets. Changes affecting Nebraska often influence neighboring states and broader agricultural systems. The drought conditions currently affecting Nebraska are not occurring in isolation. Dryness has impacted portions of Kansas, South Dakota, Colorado, Wyoming, and other areas at various times during recent years. Weather patterns rarely respect state boundaries. When precipitation deficits develop across broad regions, agricultural consequences can spread accordingly. This interconnectedness helps explain why concerns about Nebraska are attracting attention far beyond state lines. The challenges being observed today may provide insight into conditions that other regions could encounter tomorrow. The comparison to the Dust Bowl has emerged frequently in discussions about current conditions. While the historical circumstances differ in important ways, the reference reflects growing concern about prolonged drought and land degradation across parts of the Great Plains. During the 1930s, a combination of severe drought, economic hardship, and extensive cultivation practices contributed to one of the most significant environmental crises in American history. Massive dust storms swept across the plains. Millions of acres experienced erosion. Agricultural production suffered catastrophic losses. Modern agriculture operates under very different conditions. Conservation practices have improved significantly. Soil management techniques are more sophisticated. Weather forecasting capabilities are vastly superior. Irrigation infrastructure is more extensive. Farmers possess technologies that would have been unimaginable during the Dust Bowl era. Nevertheless, the comparison persists because both situations involve a fundamental challenge: insufficient moisture across a landscape heavily dependent on agricultural productivity. The modern version of that challenge may look different from the images preserved in historical photographs, but the underlying issue remains familiar. When precipitation fails, temperatures rise, and water supplies become strained, agricultural systems face mounting pressure. Climate variability adds another layer of complexity. The Great Plains has always experienced cycles of wet and dry periods. Historical records reveal recurring drought episodes extending back long before modern settlement. Yet many researchers have noted that rising temperatures can intensify drought impacts by increasing evaporation rates and crop water demands. Even when precipitation totals remain relatively similar, hotter conditions can remove moisture from soils more rapidly. Crops require additional water to maintain growth. Surface reservoirs lose water through evaporation. Vegetation dries more quickly, increasing fire risk. These factors can amplify the effects of already limited rainfall. For farmers, the practical consequences are immediate. Decisions regarding crop selection, planting dates, irrigation schedules, fertilizer applications, and harvest expectations all depend heavily on moisture availability. A season that begins with severe drought often forces difficult adjustments. Some producers may reduce planted acreage. Others may alter crop rotations. Livestock operations may confront forage shortages that require herd reductions or increased feed purchases. Every decision carries financial implications. The economic effects ripple outward through rural communities. Equipment dealers, grain elevators, transportation providers, processing facilities, and local businesses all depend to varying degrees on agricultural success. When drought reduces production, the impacts frequently extend beyond individual farms. Water management authorities also face increasingly difficult decisions. Groundwater conservation efforts must balance agricultural demands, municipal needs, environmental considerations, and long-term sustainability objectives. Those competing priorities become more challenging when water supplies are under stress. In Nebraska, as in many agricultural states, water has traditionally been viewed as both an economic resource and a strategic asset. Maintaining reliable access to water supports crop production, livestock operations, industrial activity, and population growth. Protecting that access becomes increasingly important during prolonged dry periods. The spring of this year has highlighted how quickly conditions can change. Fields that appeared promising months earlier encountered mounting stress. Water systems that normally function without concern faced unexpected challenges. Fire activity accelerated across extensive areas. Insurance claims reflected disruptions that would have seemed unlikely under normal circumstances. These developments serve as reminders that agricultural resilience depends on a complex interaction of weather, water, soil, infrastructure, and management practices. When multiple stressors emerge simultaneously, vulnerabilities become more apparent. The broader significance of Nebraska's situation lies in its potential to foreshadow challenges elsewhere. Across the central United States, millions of acres depend on similar combinations of rainfall and groundwater resources. Many communities face comparable exposure to drought risk. If current patterns persist or expand, additional regions may encounter similar difficulties. Wells that once seemed reliable may face increasing pressure. Crop losses could become more frequent. Fire seasons may grow longer and more intense. Water management decisions may become increasingly consequential. The concern is not that every area will experience identical conditions, but rather that the factors affecting Nebraska are not unique to Nebraska. Groundwater depletion, precipitation deficits, elevated temperatures, and agricultural vulnerability exist across large portions of the American interior. For now, much depends on future weather conditions. Timely rainfall can provide substantial relief. Drought conditions can improve when precipitation patterns shift favorably. Agricultural outcomes remain highly sensitive to developments during the growing season. Yet the events already observed this year underscore a reality that many communities are beginning to confront. Water availability cannot be taken for granted, even in regions long associated with agricultural abundance. America's heartland remains one of the most productive agricultural regions on Earth. Vast fields continue to supply food, feed, fuel, and raw materials to domestic and international markets. The region's farmers continue adapting to challenges through innovation, experience, and persistence. But the warning signs appearing across Nebraska are difficult to ignore. Wells drawing air during planting season, devastated winter wheat fields, hundreds of thousands of burned acres, and prevent plant claims on irrigated land collectively point toward a landscape under strain. Whether these developments represent a temporary setback, the beginning of a longer drought cycle, or part of a broader transformation remains uncertain. What is clear is that the pressures now visible in Nebraska are not confined by state boundaries. Water systems, weather patterns, agricultural markets, and environmental conditions connect the Great Plains in ways that make regional impacts difficult to isolate. The dry conditions gripping Nebraska today are being watched closely because they touch on questions that reach far beyond a single harvest or a single season. They concern the durability of groundwater reserves, the resilience of agricultural production, the management of natural resources, and the capacity of communities to adapt to increasingly challenging conditions. As summer advances across the plains, those questions will remain at the center of attention. The answers may help determine not only the outcome of this year's growing season, but also the future trajectory of America's agricultural heartland. The growing concern surrounding Nebraska's drought extends beyond the immediate challenges visible in fields and pastures. Beneath the surface lies another issue that is becoming increasingly difficult to overlook: the relationship between groundwater reserves and the future stability of agricultural production across the central United States. For decades, irrigation has functioned as a buffer against the region's notoriously unpredictable climate. Rainfall has always varied across the Great Plains. Some years bring abundant moisture, while others deliver prolonged dryness. The expansion of irrigation allowed producers to reduce their dependence on rainfall alone, creating a more stable agricultural system capable of supporting high yields even during difficult weather conditions. That stability, however, depends on a resource that accumulates much more slowly than it can be used. When water levels decline gradually over many years, the effects can remain largely invisible to the public. Farmers may need to lower pumps deeper into wells. Energy costs may rise as water must be lifted greater distances. Irrigation systems may operate longer to deliver the same amount of moisture. These changes often occur incrementally, making them less noticeable than a drought that arrives suddenly. But prolonged dry conditions can accelerate those pressures. A lack of rainfall means crops become more dependent on irrigation. Increased irrigation leads to greater groundwater withdrawals. At the same time, reduced precipitation limits the natural recharge that helps replenish underground reserves. The result can be a widening gap between water entering the system and water leaving it. This dynamic is particularly important in Nebraska because agriculture occupies such a central role in the state's economy. Millions of acres are devoted to crop production, with corn and soybeans dominating large portions of the landscape. These crops require substantial amounts of water during key stages of growth, especially during periods of intense summer heat. When moisture is unavailable from rainfall, irrigation becomes essential. Yet even where irrigation remains available, drought can still impose significant penalties. High temperatures increase plant stress and accelerate evaporation from soils. Strong winds common across the plains can further increase moisture loss. Water applied through irrigation must work harder simply to maintain crop health. The result is that producers often find themselves using more water precisely when supplies are under the greatest strain. Meanwhile, ranchers are confronting a separate set of challenges tied directly to the same drought conditions. Grasslands that normally provide grazing opportunities for cattle have suffered from limited moisture and wildfire activity. Pastures that would typically sustain livestock through much of the season may produce less forage than expected. When grazing conditions deteriorate, livestock operators frequently face difficult decisions. Some may purchase supplemental feed. Others may reduce herd sizes. Both options carry economic consequences that can affect profitability for months or even years. The widespread fires that swept across Nebraska this spring added another layer of difficulty. Beyond the immediate destruction of vegetation, fires can alter grazing plans and reduce available pasture acreage. Burned areas often require time to recover before they can support livestock again. The impact on soil conditions is also receiving increasing attention. Healthy soils act as natural reservoirs, storing moisture that plants can access during dry periods. Conservation practices implemented over recent decades have improved soil structure across many agricultural areas, helping reduce erosion and increase water retention. However, severe drought can challenge even well-managed soils. When prolonged dryness persists, soils lose moisture reserves and become more vulnerable to wind erosion. Strong winds sweeping across exposed fields can remove valuable topsoil, particularly in areas where vegetation cover is limited. While modern farming practices have dramatically reduced the likelihood of erosion on the scale witnessed during the Dust Bowl era, the underlying risk has not disappeared entirely. This concern helps explain why comparisons to the 1930s continue to surface despite major differences between the two periods. The original Dust Bowl was driven by an extraordinary combination of severe drought and extensive cultivation practices that left large areas vulnerable to erosion. Today's agricultural landscape benefits from decades of conservation improvements, including no-till farming, residue management, cover crops, contour farming, and other techniques designed to protect soil. Those advances provide important safeguards, yet drought remains a powerful force. Even with modern technology and improved management practices, a prolonged lack of moisture can place tremendous pressure on agricultural systems. The fact that such comparisons are being made reflects growing unease about the scale of the current dryness rather than a prediction that history will repeat itself exactly. Another factor drawing attention is the timing of the drought. Agricultural seasons operate according to a series of critical windows. Planting, emergence, flowering, grain fill, and harvest all occur within relatively narrow time frames. Conditions during these periods often determine the success or failure of an entire season. When drought arrives early, as it has in parts of Nebraska, producers lose flexibility, soil moisture deficits develop before crops become established, irrigation demands increase sooner, crop stress begins earlier, recovery becomes more dependent on favorable weather arriving at precisely the right moment. The reports of wells struggling in mid-May therefore carry significance beyond the immediate concern about water availability. They suggest that stress was emerging before the hottest part of the summer had even begun. Historically, some of the most damaging droughts across the Great Plains intensified during the summer months, when temperatures peaked and crop water requirements reached their highest levels. If groundwater systems are already under pressure before that stage arrives, the margin for error becomes much smaller. Communities throughout the region are monitoring these developments closely because agriculture remains deeply interconnected with local economies. Grain production supports transportation networks, processing facilities, storage infrastructure, equipment sales, and countless related businesses.